Hi, tonight's video is on scientific notation. Our standard is 8EE4. If we can go ahead and write how can I use scientific notation to write large and small numbers on the essential question, that would be great. And here we go. Scientific notation is a fancy thing you may have seen on the calculator. When a number is getting too big for the calculator, it simplifies it. It simplifies it into a multiplication sentence with a power of 10 to it. The factor then must be greater than or equal to 1 and less than 10. So you'll see things like 4.6 times 10 to the third or 7.52 times 10 to the negative third. So numbers just get shortened in a notation way, and we are going to find out how they do it. So the first thing that they do is they count the places until there is only one digit to the left of the decimal. So it has to look like 5.42 or 6.38. One digit, to the left of the decimal. It's just their standard form. Then they rewrite the multiplied by a decimal part. So they rewrite it in a new form. If the original number, I need to just switch this. This is a mistake in your notes. Greater than 1, your exponent is positive. If the original number is between 0 or 1, the exponent is negative, will be negative. You want to add that will, that'd be fine. Will be negative. So let's take a look at what this is going to look like. It's not that terribly difficult compared to what we've been working on. So this is a really large number. In order to shorten this into scientific notation, we have to build that wall. Find the place where there is one digit to the left and put the decimal place. Step 2, rewrite everything that doesn't include zeros. So in this case, we have 8 and 785 thousandths. Then we're ready for the times 10 to the power of something. We need to count how many after that new decimal place is it going to be 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. That worked out really well. 8 and 785 thousandths times 10 to the 9th power. All right, problem 2. We've got 5.42. Find where the decimal goes. One digit to the left, check. Cross off all those zeros, don't need them. Count how many spots are now to the right of that decimal place. 1, 2, 3, 4, 5, and 6. So our scientific notation becomes 5 and 42 hundredths times 10 to the 6th power. All right, moving on. There could be a very small number, and we need to make it times 10 to a negative exponent. So the same rules apply. You find where that first number to the left of the decimal place goes. You copy down the 21 hundredths afterwards. And then now we need to find out how many spots we moved over to make this possible. So 1, 2, 3, 4, 5. And it's not 10 to the 5th because we're not making it greater than, we're making it smaller. So it's 10 to the negative 5th. In example 2 of our very small numbers, we just have a 2, a lonely 2. If you want to write 2.0, go for it. So that makes it a little easier. I'm counting the spots to get after the 2. 1, 2, 3, 4, 6. And we're making sure that we put that exponent in to show that it's a very small number. All right. Then the second half of this lesson, well, they now want to go from scientific back to standard form. So our example is 7.723 times 10 to the 4th power, and we want to get back to standard form. So we're going to move the decimal point, the number of spaces that equals the power of 10, or the exponent. Let's do exponent in base 10. You don't have to add that. That's kind of wordy. Whatever you want. We're looking for that power. How much are we going to move it? If the exponent is positive, we need to move it to the right. We need to make our decimal larger because that makes sense. If the exponent is negative, we're going to move it to the left. We want to make it a smaller number. And then we'll add in zeros to fill in any spaces that we will need along our way. So, in our example, 7.723, the exponent in the base 10 is 4. It's positive. We need to move it 4 spots to the right. We need to multiply that. We've had those discussions in elementary school, so this should not surprise you. So, our new number, as we rewrite it without our messy move, is 77,230, and yes, we should be including commas at our age. So, these 4 examples are taking a look at moving the decimal to the right for positive and to the left for negative. If you want to pause it and see if you're right, go for it. So we've got 9,931. Our power of positive 5 says we're moving 5 to the right. 1, 2, 3. We need to move 1, 2, 3 and add 2 zeros. We then rewrite it and add our commas, which leaves us at 993,100. Oh boy, it looks like I got to add a lot of zeros. 1.9 is moving 1, 6, 1, 2, 3, 4, 5, 6, 7 to the right. It looks like I got lucky counting my zeros correctly. So I moved it 7 to the right. I rewrote my number and I included my commas. Done. This time, negative exponent, I need to move to the left. So 2.04, 2 400ths, and I'm moving 8 decimal places, or I'm dividing by 10 to the power of 8. 1, 2, 3, 4, 5, 6, 7. Need 7 zeros and a 2. That is such a small number. 5, 6, 7. Whoop. 2, 0, 4. All right. 6.02. I don't feel like this is moving 4 to the left. 1, and then I need 3 zeros, right? Check to make sure that that is 4. 1, 2, 3, and 4 to the 6. It is. Rewrite so it doesn't look messy. And you can say the place value if you'd like to yourself. I will see you tomorrow. Thanks.